grade 8 learners, welcome to today's Natural Sciences lesson. My name is Pathuchezo Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area Metal Materials. The topic is chemical reactions, and the subtopic is reactants and products. It is reactants and products. All right, let's move on to today's lesson objectives. So this is what we want to achieve by the end of today. So at the end of the lesson, you should be able to explain the concepts, chemical reaction and chemical bond, identify whether a reaction has taken place or not, explain the concepts reactant and product, identify reactants and products in a chemical reaction, draw models showing chemical reactions, and explain reactants and products through indigenous knowledge of the fermentation process. And all of this is sourced from your CAPS document on page 45. Let's move on to pre-knowledge. So pre-knowledge is what you've been learning prior to today's lesson. It has laid the foundation of today's lesson. In the 8th grade, which is the current grade that we're in, we learned about atoms. We learned about the synthesis or formation of compounds, and we also learned about decomposition of compounds. So I've put up a picture here with me just to help remind you of our prior knowledge before we move on to the next slide. So if you remember, we said for a compound to be formed, there has to be some kind of rearrangement of atoms of different elements to form a compound. So that is the synthesis or the formation of compounds. So if you look at my diagram here, I've got A and B, and then we bring them together, we end up with a compound AB. And then in decomposition of compounds, if you remember the experiment that we did when we were decomposing potassium permanganate, right? So we've got compound AB there, and then we use either electrolysis or thermal decomposition to decompose the compound. So this is where we are starting from and continuing further. So let's look at today's baseline assessment. I'm going to read out the questions for today's baseline assessment and then give you time to answer the questions. And as soon as you are done, we can go through the solutions together. Let's read the first question. So the first question reads, what is a chemical reaction? The second question is, what happens to atoms and the bonds between them during a chemical reaction? And the third question is, give the name of the compound formed from sodium and chlorine. So I'm going to give you 2 minutes to answer these questions. Don't forget to send through your answers to 0794549535. See you after 2 minutes. Welcome back, grade 8. So now let's look at the solutions to our baseline assessment. Don't forget to send through your answers to 079-454-9535. So the first question read, what is a chemical reaction? What is a chemical reaction? So if you remember from the previous lessons that we had, we defined a chemical reaction as a process that occurs when atoms of elements or compounds are rearranged to form new substances. So they get rearranged and then they form new substances. So that is what we call a chemical reaction. And then our second question read, what happens to atoms and the bonds between them during a chemical reaction? So during a chemical reaction, this is what happens. Bonds of reactants break and new bonds are formed to produce new products. Just to further explain this answer, right? So remember we said a chemical reaction is where there is a rearrangement of atoms of elements or compounds to form new substances. So meaning that before the rearrangement, there was an existing rearrangement, an initial arrangement before the rearrangement. Now, so during a chemical reaction, those bonds, remember we defined the bond, a chemical bond in our previous lesson as a force that holds atoms together. So as the atoms are being rearranged, what do you think is going to happen to that force that is holding the atoms together? It is going to break. So now, bonds will break and then new bonds will be formed. So that is what happens to atoms and the bonds between them during a chemical reaction. And then the third question read, give the name of the compound formed from sodium and chlorine, which is sodium chloride. Do you remember what sodium chloride is? It is the table salt, the common table salt that we use. So now let's move on to terminology. So these are the terms that we're going to come across during the course of the lesson. So now they're going to help us to understand deeper the concepts that we're learning today. So let's see which one is our first term today. So the first term is reactant. Reactant. So a reactant is a substance that takes part in a chemical reaction and undergoes change. So it takes part in a chemical reaction and it undergoes change. So you should be thinking by now, so it starts as something else and then ends up as something different. And then the next term is product. Product. So a product is actually a substance that is produced after a chemical reaction has taken place. So when a chemical reaction happens, now what we get at the end of it is a product. We call it a product. And then the third term is chemical reaction. What is a chemical reaction? We've defined it already. We said it's the process that occurs when atoms of elements or compounds are rearranged to form new substances. Let's look at the next three terms. So the fourth term is chemical equation. Chemical equation. I know you've met or you've come across equations in your mathematics. Well, in natural sciences, we also have equations and we call them chemical equations. So chemical equations, what are they? A chemical equation is a symbolic method that is used to represent chemical reactions. It is a symbolic method used to represent chemical reactions. If you remember when we're learning about the periodic table, we said we represent the names of elements through symbols. Do you see where I'm going with this? What is a chemical bond? We have defined a chemical bond in our previous lesson, but it doesn't hurt to redefine it again. So a chemical bond is a force that holds atoms together, be it in a diatomic molecule or in a molecule of a compound or in a compound. That force that is holding the atoms together and keeping them from coming apart is called a chemical bond. And then fermentation. Fermentation is actually a type of a chemical reaction. So it is a chemical reaction in which alcohol is produced from sugars. Fermentation is a chemical reaction in which alcohol is formed from sugars. So fermentation is actually one of the chemical reactions that you will learn about in the future. Okay, so now let's move on to the next slide. So in our next slide, the question is, what is a chemical reaction? What is a chemical reaction? Think about it. Right, we've defined it already in our terminology. We said it is a chemical change in which one or more substances are broken down and one or more new substances are created. So remember, in our previous lesson, we talked about a rearrangement of atoms. So now we've added more information to what a chemical reaction is. So we have a starting substance. We have an initial substance. So that substance is going to be broken down into something new. So we are forming something new from something old. So that is a chemical reaction. So we have what is called before. So before a chemical reaction is initiated, we are going to have different elements or different compounds. So in this example, now before our chemical reaction, we have hydrogen gas and we have oxygen gas. Remember, hydrogen and oxygen exist as diatomic molecules. So that's why we have that subscript there. That little 2 over there, it's just reminding us that it's 2 atoms of hydrogen that are bonded together. So I'm going to pull up a picture now. So this is before the chemical reaction. So we've got hydrogen and we've got another hydrogen diatomic molecule, and we've got oxygen as well. So this is what we have before the reaction. So these are the substances. So now we said in a chemical reaction, we break down substances. So we're going to break these down, and break those down. So once we break them down, we will end up with new substances. So these are our new substances. That compound that has a hydrogen atom, another hydrogen atom, and an oxygen atom. We've got another one which is identical, another new substance which is identical, which has a hydrogen atom, another hydrogen atom, and an oxygen atom. So after we have formed water, remember we've said water is a molecule of a compound. We have formed water, yet initially we had hydrogen gas and oxygen gas, and after the chemical reaction occurred, we ended up with a new substance which is water. So we broke down the hydrogen and oxygen molecules, rearranged everything, and then ended up with a water molecule. Now, let's talk about the parts of a chemical reaction. Remember, we said in the previous slide we had a before, and we had a during, and then we had an after. So let's talk about the parts of a chemical reaction. So in a chemical reaction, we have 2 parts. We have what are called reactants, and we have products. Remember, it's our subtopic for today, reactants and products. So we have 2 parts in a chemical reaction. We have reactants and then we have products, something old and something new. Okay, so reactants are substances that are broken down by a chemical change. The bonds break. Remember in our baseline assessment when we were talking about a bond that has broken, what happens to the atoms, what's the bonds between the atoms during a chemical reaction. So the reactants bonds break. The force that is holding the atoms in a reactants, they break. Okay, so what about products? So products are new substances. So substances created by the chemical change. So here we have new bonds forming. We have new bonds forming here. Right, and then there is an arrow. So we always have an arrow between reactants and products, and the arrow is always pointing towards the product. Remember, an arrow has one end, the pointing end. This pointing end. That pointing end is always pointing towards the products. So the arrow is read as yields or produces. It is read as yields or produces. Let's try and read this statement here up above here. So reactants produce products. Read it as yields or produces. Read it as yields or produces. So now let's talk about reactions. Reactions. So now in a reaction we have a plus sign that we usually write in a chemical reaction. So the plus separates two or more products. It separates two or more products. And then remember the arrow? The arrow is telling us that we are yielding, we are producing, and that arrow separates reactants and products. So I have a chemical equation. Remember we said by the end of today's lesson, we're going to be able to understand or to identify a chemical reaction and explain it and describe it. So I've got a chemical equation, which is a symbolic representation of a chemical reaction. Right. So this is a chemical equation. So we've got reactant A and reactant B. And then we have product C and product D. Remember we said the plus sign will separate two or more reactants or will separate two or more products. So if we have more than one product, we add a plus sign, and if we have more than one reactant, we put a plus sign between the reactants. And then we have our yield sign. There is our yield sign. And this is something of you to note. It is quite important. In a chemical reaction, the reactants are always on the left side of the arrow. They're always found on the left side of the arrow. And then the products are always found on the right side of the arrow. They're always found on the right side of the arrow. So let's move on to evidence. Evidence of a chemical reaction. So if a chemical reaction has occurred, if there has been a chemical reaction, there should be some kind of evidence that we should look out for. Remember, in science, we always use our observations to come to conclusions. We observe in different ways. We can see, we can smell, we can feel, we can taste, or we can feel the change of a temperature and so forth. So now there are different ways in which we can prove or in which we can tell that a chemical reaction has happened. So the first one is evolution of light or heat. So if there is light produced, then we know that there has been a chemical reaction. For example, think of the fluorescent lights that you may have in your kitchen or at schools, those long ones. They produce light. Those fluorescent lights produce light. So you know that there is a chemical reaction happening in those tubes, in those lights. So if there's evolution of light, then we know that there has been a chemical reaction. If we look at these fluorescent lights here that I have in this diagram here, these lights, if we look at A here, this is before the chemical reaction, and then B. So something must have happened between A and B in order for a B to start glowing. So a chemical reaction has taken place. There has been evolution of light. And then the next way that you can tell that there has been a chemical reaction is when there is a temperature change. It can go both ways. It's either the temperature change is an increase or a decrease to the surroundings. So there can be a temperature change. That's another way that you can tell that there has been a chemical reaction. I've got a diagram with me here to help us explain this, what we're saying here. So it can go both ways. There can be absorption of heat. So when ice is melting, there is absorption of heat. If you remember when we're learning under the particle model of matter, we learned that when atoms or when particles gain energy, the substance can change its state. So here, absorption of heat, gaining of energy of the solid particles has helped it to change. So if there is heat being absorbed, then we know that there has been a chemical change. And then release of heat. Here we've got wood reacting with oxygen. We've got wood reacting with oxygen, producing this lovely orange flame. So if there is release of heat, or if there is production of heat, then we know that there has been a chemical reaction. There's a third way. Formation of a gas. Formation of a gas. What do I mean by formation of a gas? Other than boiling, it's not boiling, other than boiling, bubbling or production of an odor. An odor is a smell, boys and girls. An odor is a smell. So if there are some bubbles being formed, or there is a certain odor that you can smell, then a chemical reaction may as well have taken place. So I've got an illustration with me here. So in my illustration, I took a pill and I put it in a glass there. You see the bubbles that are forming there. That is an indication that a gas is being formed. If we can just harvest that gas, we can actually find out what gas it is. Remember, with our decomposition experiment, we brought the the glowing splint towards the mouth of the test tube, and then it relighted. That's when we knew that this gas that has been produced is oxygen. So now you see those bubbles. It is evidence that there has been a chemical reaction, and that chemical reaction just produced a gas. And then 4. Now this is the fourth way we can tell that there has been a chemical reaction. If there is a color change due to the formation of a new substance. Remember, in a chemical reaction, we are saying that reactants change into products. So if the reactants have been broken down and the new substances, which are products, have been formed, there is going to be a color change. I've got 2 diagrams actually. I'm going to start here with the first one. So these are iron sheets. These are iron sheets. Maybe it's someone's roof. Alright, so the initial color was gray. This color that is here, I'm just going to be scribbling in the gray parts. That is the initial color. So the initial color is gray. So now in the initial color here, do you see, other than the initial color, there are some spots that are brick red. There has been a color change, which means this substance that is brick red is quite different from the substance that is gray. So there has been a new substance that has been formed. So there has been formation of a new substance. I've got another picture with me here. So these were 2 chemicals. These were 2 chemicals here. So the first one was a clear color, and then the second one was purple. But when the 2 were mixed, the end result is green. The end result is green. So the new substance is different from both of the old substance, so from both reactants. The product is different. The color of the product is different from the color of the reactants. The first one is clear, the second one is purple. So, and then the product is green. So there is a difference between the reactants, the color of the reactants, and the color of the product. So that is another way we can tell that there has been a chemical reaction. And then the 5th way we can tell that there has been a chemical reaction is the formation of a precipitate. I know this is a new word and it's quite a mouthful, isn't it? A precipitate. So with precipitates, what is a precipitate? It is a solid. It is a solid. So formation of a precipitate, a new solid, from the reaction of 2 aqueous solution. So 2 solutions, when you mix 2 solutions and then a solid is formed. When you mix 2 solutions and then a solid is formed, that is what we call a formation of a precipitate. So here's the picture here. So solution number 1 is clear, and what we're pouring into the beaker is also clear. But the result of reacting the 2, the result of reacting the 2 reactants, reactant A here and reactant B, the result of the 2 reactants is this yellow precipitate. We'll call it product C. So formation of a precipitate is another way in which we can tell that there has been a chemical reaction that has happened or that has occurred. So let's talk about chemical word equations. Chemical word equations. Before we go into chemical word equations, there are three ways in which we can represent chemical equations. We can use word equations, symbolic equations, and we can use pictures. We can use three ways. So let's start off with the first one, which is chemical word equations. So these are statements that indicate the reactants and products in a chemical reaction. So remember we said a chemical equation is a symbolic way. It's a statement which is a symbolic way of representing a chemical reaction. So now with word equation, it is actually a statement. So here is an example of a word equation. Carbon plus oxygen to give us carbon dioxide. Carbon plus oxygen to give us carbon dioxide. Remember earlier on in today's lesson, we said reactants are always found on the left-hand side of the arrow and products are always found on the right-hand side of the arrow, and the arrow always points towards the products. Make sure when you're writing your word equation, your chemical word equation, your arrow is pointing towards the product, and you write your reactants on the left-hand side, and then you write your products on the right-hand side. Always make sure of that. This is how we read a chemical word equation. This is how we read it. We say carbon and oxygen. So the end is the plus. The end is the plus. Remember, here's a plus. So carbon and oxygen react, the arrow, react to produce carbon dioxide. React to produce carbon dioxide. So that is how you read your word equation. That is how you read your word equation. Right, so that is a diagrammatical representation of dry ice, your carbon dioxide. So how do you translate word equations to symbol equations? Remember, elements are represented as symbols in our periodic table. So we actually want to use those symbols in chemical equation. So let's find out how we can translate word equations to symbol equations. So a symbol equation uses chemical formulas rather than words to identify the reactants and the products of a chemical reaction. It uses symbols. Remember, we can get our symbols from our periodic table of elements. So if the word equation is carbon reacts with oxygen to produce carbon dioxide. Remember, that's how we said we're going to read. Carbon reacts with oxygen to produce carbon dioxide. So the symbol equation is going to be C plus O2 to yield carbon dioxide. Remember, if you refer back to your periodic table of elements, the symbol for carbon is C, the symbol for oxygen is O, and the symbol for carbon dioxide, the chemical formula, we said it was CO2. Remember when we were learning about atoms. And when we're building atoms. Okay, so now C is representing carbon. There we go. O is representing oxygen, and CO2 is representing carbon dioxide. Just a quick refresher. Can you identify the reactants and the product in this particular equation? Well, if you've forgotten, I can remind you. This side here, on the left-hand side of the chemical equation, we have our reactants. I'll represent them with the letter R. We have our reactants, and our reactants are carbon and oxygen. Those are our reactants. If we look at the right side of the arrow, where the arrow is pointing to, we have carbon dioxide, and this is our product. this is our product. So our reactants are carbon and oxygen, and our product is carbon dioxide. Our product is carbon dioxide. So that is our symbolic equation. So now the third way in which we can represent equations is by using pictures. So all chemical equations use formulas to represent substances that are involved in the reaction. So far we've learned about word equations. We learned about symbolic equations. Now the third way in which we can represent our equations is by pictures, our picture equation. So to draw a picture equation, you need a key for the reactants and products. Why are we saying key? What is a key? Now, a key is what actually tells you a key is a representation of the specific element or the specific compound. So you need a key in order for you to draw the pictures of your reaction. Now, let's look at these pictures here. So we've got hydrogen and oxygen, and these are our reactants. Then our product is water, as indicated here. That is our product. Water is our product. So now let's come up with pictures to represent this chemical equation. So you need to make sure that the picture or the drawing of hydrogen is different from the drawing of oxygen, as well as the drawing of water. So the drawing of oxygen, water, and hydrogen should be different. So this is where the part about the key comes in, the key that I spoke about earlier. So I have chosen blue circles. To represent my hydrogen. I've chosen blue circles to represent my hydrogen. We should be able to differentiate between the atoms of elements or the different compounds in a picture equation. So now I have chosen blue circles to represent hydrogen. I've also chosen red circles to represent oxygen. We need not choose a different color for water, because remember, in a chemical reaction, we are rearranging, we're breaking the bonds between the atoms of elements and molecules that are the reactants, and rearranging them to form new substances. So we don't need to find a new key or a different color for the water. Remember, the water is a new substance that we are forming from hydrogen and oxygen. So now, if we react hydrogen and oxygen react to produce water. So we've got our blue circles there, bonds between the blue circles and bonds between the red circles being broken, and then a rearrangement happens, and then we end up with new bonds forming. So the reason why our hydrogen and our oxygen are in twos is, remember when we're learning about molecules, we said some atoms of some elements react, or rather they naturally occur as diatomic molecules. So hydrogen and oxygen are one of those elements whose atoms naturally occur as diatomic molecules. So the bonds between the diatomic molecules break. So when the bonds between the diatomic molecules break on the reactant side, remember, keep in mind this is the reactant side, new bonds are formed. So the new bonds are between hydrogen and oxygen, hydrogen and oxygen, hydrogen and oxygen, and hydrogen and oxygen on that side to form our product, which is water. So if we're going to be reading this equation, we're reading it as hydrogen reacts with oxygen to produce water. Hydrogen reacts with oxygen to produce water. Hydrogen and oxygen react to produce water. And then at the bottom there, I've just added the symbolic equation. Just to remind you guys, I've added this symbolic equation. Remember, the symbol for hydrogen is H. If you check the periodic table, the symbol for hydrogen is H. The symbol for oxygen is O. So hydrogen reacts with oxygen to give us water. Hydrogen reacts with oxygen to give us the molecule of a compound water, which comprises of hydrogen atoms and an oxygen atom. So now let's move on to today's first activity. So today's activity, you're going to have to refer to this diagram for all of the 3 questions. You need to refer to the diagram to answer all of the 3 questions. So I'm going to read the questions first and then give you time to answer them. So the first question reads, what are the reactants in this reaction? The second question is, what is the product in this reaction? And then the third question is, why do you think hydrogen and oxygen are represented as 2 atoms joined together? Why do you think hydrogen and oxygen are represented as 2 atoms together? So I'm going to give you 3 minutes to answer these questions. Don't forget to send through your responses to 079 454 9535. So see you after 3 minutes. Welcome back, grade 8 learners. I hope you're sending in your answers to 079 454 9535. Now let's go through the solutions together. So remember, I said we refer to the picture. We refer to the picture for our solutions. Right, so the first question read, what are the reactants in this reaction? What are the reactants in this reaction? If you wrote the molecules on the left side of the arrow, which is hydrogen and oxygen, the molecules on the left side of the arrow, which is hydrogen and oxygen, those are the reactants of today's reaction. Those are the reactants to the reaction. And then the second question read, what is the product in this reaction? What is the product in this reaction? So the product in this reaction is the compound on the right-hand side of the arrow, which is water. So this is the left-hand side of the arrow, that is the right-hand side of the arrow, and the arrow is pointing. Oh, my arrow is a bit skewed. Let me just write it down quickly. Right. So, and then now we have our arrow there. So the arrow always points towards the product. The reactants are always on the left side of the arrow, and the products are always on the right side of the arrow. Next question. What do you think hydrogen and oxygen are? Why do you think hydrogen and oxygen are represented as two atoms joined together? This is because they naturally exist as diatomic molecules. Remember when we're learning about molecules and compounds, we said some atoms of elements exist as diatomic molecules, and we remember there is 7 of them. So hydrogen and oxygen are actually part of that group that exist naturally as diatomic molecules. So always remember, that is the reason why we represent them as atoms joined together. Just for interest's sake, you see these pictures? So that's your picture equation there. Let me just put a plus sign there. So that is your picture equation. This is your symbolic equation. And if I put a plus sign and an arrow, that becomes your word equation. And then we have all 3 representations of chemical reactions in one picture. Okay. Now let's move on to applications of chemical reactions. Applications of chemical reactions. What do we need chemical reactions for? What do we use chemical reactions for, and where? Okay, so let's start. So a fermentation reaction takes place when the reaction between sugar and yeast produces alcohol and carbon dioxide. Remember when we were doing our terminology section, we said fermentation is a type of a chemical reaction. So we can apply our knowledge of chemical reactions to fermentation, the process of fermentation. Now, so during the process of fermentation, a microorganism, yeast, reacts with sugar to produce alcohol and carbon dioxide. Just from looking at the statement here, it looks like a word equation. It sounds like we're reading a word equation, doesn't it? So now we have our reactants, your microorganism or your yeast, and we've got sugar. Those are our reactants. Those are the ones where we're having bonds broken between the atoms or compounds to form something new. Now, what are we producing? We're producing alcohol and carbon dioxide. So those are our products. So the reactants in fermentation are a microorganism or yeast and sugar, and the products of fermentation are alcohol and carbon dioxide. So let's look at the word equation, how we represent fermentation in a word equation. So we say sugar, it could be glucose, reacts with yeast to produce ethanol, that is the alcohol, and carbon dioxide. So this is a representation of a fermentation reaction, Now, we've got different kinds of brews that we can come up with when we do the fermentation process. So the first one is umqombothi. It is a traditional drink made from maize yeast and water. We also have maheu. It is a fermented drink prepared from sorghum. Those are the 2. And then we've got an extra third one. I'm sure you've seen it in the cupboards at home. Apples are actually fermented to make apple cider vinegar. I'm sure you've seen apple cider vinegar in the kitchen cupboards at home. It is a product of the process of fermentation. It's a product of the process of fermentation. So these are the 3 examples we have: umqombothi, amaheu, and apple cider vinegar. So those are the applications of chemical reactions. Those are the applications of chemical reactions. So next, I'm going to give you an activity just to jog your memory a bit on what we've been learning. So in our activity, we've got this question. The question reads, the basic reaction in the fermentation process can be summarized as follows. Glucose plus yeast to produce alcohol and carbon dioxide. What are the reactants and products for this reaction? I'm going to give you 2 minutes to answer this question. Don't forget to send through your answers to 079 454 9535. Welcome back, grade 8 learners. Now let's answer this question. Let's read it once again. The question read, the basic reaction in the fermentation process can be summarized as follows. Glucose reacts with yeast to produce alcohol and carbon dioxide. What are the reactants and products of this reaction? What are the reactants and products of this reaction? So the reactants are glucose and yeast. Remember, we said we always find the reactants on the left side of the equation. Always find the reactants on the left side of the equation. That is glucose and yeast. Now, what about the products? Which ones are the products? Here, the product is alcohol and carbon dioxide. We always find them on the right side of the arrow. So we are reacting glucose and yeast to produce a new substance, which is alcohol, or new substances, which are alcohol and carbon dioxide. Remember when we learned about evidence of a chemical reaction having taken place? Carbon dioxide is a gas. So here's evidence of a chemical reaction, production of a gas. So carbon dioxide is a gas in this particular instance. Now, let's answer some more questions. Now, this is our third activity. Now, in South Africa, one of the popular drinks is maheu. Maheu is made from sorghum and water in the presence of heat. Okay, so the bubbles formed during brewing of maheu are bubbles of carbon dioxide produced by the bacteria during fermentation. Now, A, what are the reactants in this reaction to make maheu? B, name the products of this chemical reaction. C, what is the gas produced in the production of maheu? D, where do you think the gas came from? Where do you think the gas came from? So you are going to use the insert to answer those questions. Use the insert to answer those questions. So because this is a much longer activity, I'm going to give you 5 minutes to answer these questions. And then after 5 minutes, then we can go through the solutions together. Don't forget to send through your answers to 079 454 9535. Welcome back, grade 8 learners. Now let's go through the solutions. So A, the question reads, what are the reactants in the reaction to make maheu? It is sorghum and water. Why are we saying it's sorghum and water? Let's go back to the insert. It says maheu is made from sorghum and water. So that's where we got the answer from. So those are the reactants. And then the question says, the second question, which is B, reads, name the product of this chemical reaction. Name the product. It is carbon dioxide and maheu. Right. Why are we saying that? Let's go back to the insert. We need to go back to the insert so that you're seeing where we are getting these solutions from. So the bubbles formed during brewing maheu is carbon dioxide. And the other way where you can tell if maheu is really one of the product is the second sentence that says maheu is made from. Telling us that maheu is product 1 and the second product is carbon dioxide. It is formed during the brewing of maheu. So those are our two products. Remember, in the equation, where do we find what? We find the reactants on the left-hand side of the arrow and we find our products on the right-hand side of the arrow. Right, the reactants are broken down to form new substances, which are products. Now, C reads, what is the gas produced in the production of maheu? So we're looking at the products. Now because we're working with the word produced. So we're looking for products. So which of these two, carbon dioxide and maheu, is a gas? Which one is a gas? It is carbon dioxide. Why are we saying it is carbon dioxide? Let's go back to the insert. The bubbles formed during brewing of maheu are bubbles of carbon dioxide. Remember, when we're learning about evidence of a chemical reaction having occurred is the production of a gas. It can be through bubbles or a smell. So in this case, it is bubbles. So that is how we know that carbon dioxide is the gas that is produced during the production of maheu. Now, D, where do you think the gas came from? It came from the fermentation process of sorghum. Remember, we said the reactants are sorghum and water. So as we ferment the sorghum, there is gas that is produced. As we're breaking down the sorghum, there is a gas that is produced, and that gas is carbon dioxide. Okay, grade 8 learners, now let's move on to the summary. So now we are going to bring everything together, everything that we have learned in today's lesson. Let's summarize our lesson. So firstly, we learned that a reactant is a substance that takes part in a chemical reaction and undergoes change. So reactants are actually taking part in a chemical reaction and they're undergoing change. What is happening to them? Remember, if all matter is made up of particles, we talk of these particles as atoms. So the bonds between the atoms in a reactant undergo change. They are broken. So a reactant will undergo change in a chemical reaction. We also learned about products. We learned that a product is a substance that is produced after a reaction has taken place. A chemical reaction has taken place. So as soon as our reactant undergoes change, we produce a product that is produced after a chemical reaction has taken place. And then we learned that a chemical reaction occurs when substances react to form new substances. So our reactants react during the process of a chemical reaction to produce new substances. Reactants react to produce products. Simple enough, isn't it? We also learned that a chemical equation is a symbolic method that is used to represent chemical reactions. Remember, we're dealing with elements here, and we have our periodic table of elements. We've got the symbols. Do you remember the three ways in which we can represent our chemical equation? We said we use symbols, we use words, and we use pictures. Those are the three ways in which we can represent a chemical reaction. We use symbols, words, and pictures. And then we learned that a chemical bond is a force that holds atoms together. We learned something very special about chemical bonds. With the reactants, chemical bonds between the atoms of a reactant break during a chemical reaction. They break, and then there is a rearrangement of atoms. Once there is a rearrangement of atoms, new bonds form. New bonds form between different atoms of elements or compounds. So knowing about chemical bonds is very important, because during a chemical reaction there is breaking of bonds and formation of new bonds. So breaking of bonds in the reactants and formation of new bonds to give us the new substances, which is our product. So knowing about a chemical bond is very important. And then at the end of the lesson, towards the end of the lesson actually, we learned about fermentation. So fermentation is a chemical reaction in which alcohol is produced from sugars. Do you remember the three examples that we gave? We gave an example of umqombothi, apple cider vinegar, and maheu. We also had an activity, right? Do you remember the basic equation for fermentation? So the basic equation for fermentation is your sugars, it could be glucose, reacts with yeast to produce alcohol, which is ethanol, and water. That is the basic equation for fermentation, the general equation. Always keep that one in mind. So that is what we learned today. Okay, grade 8, thank you so much for joining me in today's lesson. Don't forget to sanitize, wear your mask, and keep social distance. Keep learning, keep reading, and see you next term.